Yeah, grab one from that bin there. Okay. Okay. So probability and odds, they're related. They're related, but they're different. Okay. No. But we're going to talk about the difference. Are we going to flip them? No. Rich, please and thank you. Okay, before I start, you need to know that there's actually always two different kinds of probabilities. Always. So for example, what's the probability of me tossing a coin and it landing on heads? What's the probability? You should know this one. 50-50, we always say, one out of two, right? So that's a beaver. I don't know. This is heads, right? Heads or tails, I guess. Beaver tail, right? So that is in theory, theoretical probability. So does it mean that if I flip this 10 times, should I get heads 5 of them? Theoretically, yes. But do you think that's actually going to happen? Yes. Experimental. Zach, listen to what Zach just said. There's theoretical probability and there's experimental probability. So let's toss it 10 times. Okay, you keep track of how many times you get heads. I'm going to do that on the side here. So flip it. 1. Oh, so two tosses, right? No, it's not happening. That's 3, 4. Not happening. Yeah. What am I at? 6? 5 tosses, thank you. See? Helper. This is already 6, 7, 8, right? 9. This is it actually worked out. So my experiment sort of didn't work out too well. It actually is 5. It landed on heads 5 times and 5 times on tails. So in theory, that's what we expected, but in reality, it's not always going to be the case. Okay. You want what? You want theoretical. Write that down at the top. Theoretical versus experimental probability. You want those to be close to equal. And this is what we're going to base that on, a sample size. Sample size or trials. That is what makes the difference, okay? Sample size or trials is what's going to bring these two probabilities closer together. You need to experiment more, okay? You need to toss the coin more times. You need to roll your die more often. For example, same here. If you want to know who people are going to vote for as our next prime minister, right? Is it fair to just ask maybe 100 people? Would that be an accurate sample size? No, there's like 30 million or 35 million people in Canada. You would have to ask more, and not just ask more, you'd have to ask different age brackets, right? So you want to diversify it and you want to ask more, okay? Yeah. There was that, and possibly I was talking about the number of undecided voters. They just made up their mind last minute, or they didn't tell you. They didn't tell. They wouldn't want to tell. There's a lot of people that are they want their privacy. So it's like, I'm not going to tell you who I'm going to vote, and it's rightly so. You have the right to keep it private, right? So that's probably sample size maybe and undecided voters. And did you follow when Trump won the first, like, that they were way off? Yeah, I think it had to do with the same undecided voters, voters not disclosing who they're going to vote for. Okay. I want you to add some more. Hold on. If you flip over to that next page, and if you're worried about simplifying fractions, we're not going to worry about that just yet. Okay, so flip over to page 144. I'm gonna say that one more time. Theoretical. Make sure you write this down because I'm gonna add to it. Theoretical probability. And on the other side, we're going to do experimental probability, right? So there's a versus, right? Theoretical is what should happen. And that is based on total possible outcomes. Okay? That is theoretical. It will tell us what should happen, and it's based on the possible outcomes. So if you look at a die, it has 6 numbers, right? There's more, right? But a standard die has 6 outcomes. Experimental is what actually happened, and it's based on trials or experiments. Okay, so that is one big box that I want you to always remember when we're calculating. That's something to keep in mind. Probability in general is the likelihood, right, of an event happening. And we can state it in 4 ways, right? State it as, you can go decimal, fraction, percent, or words. Words we don't really use that it doesn't come up very often, but you can state it in various ways. So let's go. Decimal would be 0.25. That would be a quarter, which is 25%, which is 1 out of 4, right? So there you have examples right underneath it. Probability of the event. Okay, that's how we write. Often we will go P of whatever you're after, right? Probability of event is favorable outcomes divided by total possible. Okay, that is basically your formula to come up with probabilities every single time. Okay. Then we have odds. How many of you have heard the term odds? When do we use it? When is it used most often? Betting. Betting, right? When teams are gonna verse each other, there are odds, right? How do they come up with these odds? well, it's actually very complicated. Like the previous performance, but then right as the beginning of the season, you're like the new players, right? So they kind of base it a little bit on previous, a little bit on what kind of players are on the team. It's very complicated, but it goes based on performance quite often. Also the name of the team, right? Like how have you been doing historically speaking, right? But odds, you write it like this. It compares favorable and non-favorable outcomes. Okay, so written as for, right? And here you go against. Okay, an example, right? The odds of it snowing tomorrow could be 2 to 5, right? Something like that. And we're not going to go into details right now as to how we come up with them. That I will cover in a bit. But you need to know the difference between odds and probability. I'm going to highlight that, right? And I want you to know that the biggest difference, right? Odds here, that you're going to have the colon in between every time. Okay, no total ever. I'm going to write that down because you're going to review. Okay, no total should appear. So let's just do a quick example. There are 5 days usually in a school week, right? If I'm late once, so now we're going to talk about my odds of being late, right? So it'll be 1, 2 out of 5 days, right? I was late once. What number would come on this side here? The number of times that I'm not late. 4, exactly. Okay, so I'm going to say this is late, and this is not late. I want you to think of late, not late, winning, not winning, more so than anything else. So you should not have a 5 there, for example. We just talked about that there are 5 days. That'll be the total number of days. Okay. Okay, you know what it says underneath here? Simplify the fractions here. I'm not going to do that because that's not right now. That's not my priority. I do want you to learn how to state it as a decimal and as a percentage. Okay, so we're going to go this decimal. Actually, before I do that, let's figure out what this is as a decimal. So grab your calculator. I'm going to grab my calculator. Okay, turn that into, just don't write it down. Just in your calculator, turn that into a decimal. So we go 45 divided by 72, right? You always have to divide them. And in this case, it's a nice, it's finite. It stops, right? There's only 3 decimals. So I want you to take this is from your calculator, and then you turn it into a decimal. So decimal, because it stops, we can just say that it's 0.625. If you want to turn that into a percentage, what do you need to do to this number? That's been a while, right? Multiply it by 100. So it's 62.5%. I will do this, multiply by 100, right? Let's do a couple more. This one right here, 168 divided by 294. Write down what it says on your calculator, 0.5 5, 7, 1, 4, 2, 8, and it keeps going, right? If you turn this into a decimal, follow me here, okay? This is going to make your life a lot easier if you know what you're doing. If you turn it into a decimal, I quite often state it in 4 decimals. You're like, Mr. Dirksen, we always said 2. 2 is fine, but I would go 4. So 1, 2, 3, 4, cut it right here. What's the 2 going to do to the 4? Is it going to affect it? No. So it's 0.5714 done. And then if you want to turn that into a percentage, all you do is you take what's on your screen, you go times 100, and that is 57.14%. There I go 2 decimals, and you're like, why are you doing that? What? Because technically, you can go from here to here just by multiplying that by 100, right? And you see that it's, because if you pay attention to this, if you turn this to 0.57, right? And I ask you, hey, state this as a percentage, and you just said 57%, you would actually be wrong, okay? That's how the province wants you to say it. It wants saying, go to your calculator. If it's decimal, you can do that, 0.57, okay? But if it's percent that they're asking for, you take your number, multiply that by 100, and then round it to 2 decimals, okay? Let's see if you know what I'm talking about. You try these two, see if you can get those right. Go for it. I'm going to... Let's see here. 675 divided by 1575. That is, I'm going to write this down here for illustration purposes, right? And then I'm going to say, well, you know what? Is this correct to state it like that? If I asked you as a decimal, you're looking up, some of you are looking down. Yes, that would be right. So how about, let's do that. And then as a percentage, I take my number and multiply that by 100 or shift the decimal over 2 places. It's up to you. And that turns into 42.86%. Okay. So see how they're not quite the same. So that's what I want you to avoid from doing. I don't want you to turn that into a 43% all of a sudden. Here, another one, 54/81. 0 points. Keeps going, right? So that would be 0.67 as a decimal. And if you want percentage, right? There you go. So I hope you understand that. It's not too bad, is it? Okay, follow me now. So a little bit of that, I had to cover the basics there. I will do the first 3 here. A chart like this is very popular in this unit. I will do the first 3 and then I'll add a few and let you try those as well. Okay. So if you have a fraction and you want to turn it into a decimal, you should already know how to do that. 1 divided by 5, that's 0.2. Turn what's in your screen to a percentage. So that's 20%, right? We're on page 145. So you got that. I actually, when you're given a fraction, you can go over and over, right? What about this? A decimal. Watch carefully here. This might be a blast from the past for you. I don't know. I don't know if you were taught this. Were you taught to go from a decimal to a fraction? It's hard, right? So watch this. Do you need that 0 there? You don't need that 0 there. Cancel it. Get rid of it. 0.7. What you do here is this. How many decimal places do you have? The answer is 1. That means that you'll have 10, like it's 1 0 that you tack onto the denominator. So there will always be a 1, and then you just count the number of decimals. If there had been 2 decimals, you would have added 2 zeros here, right? And so then next you grab that number itself, which is 7, and you've got yourself a fraction. Okay? Percentage, you can just take that, multiply that by 100, you get 70%. Okay? So what I did here is I went like this, times 100, and this you're just going to have to remember, right? But I did branch off to that side as well. One more. Percentage. I'm going to turn that into a decimal. I'm going to go divide it by 100. Right? Take that number, do it with me. 12.5 divided by 100. That is my decimal. Don't get rid of anything when it's like that. When it stops, just use the whole number. This is where it gets tricky. How would you turn this into a fraction? Well, I'm glad you asked. I'll put a 1 here and I count how many decimals. 1, 2, 3. That means that there will be 1,000 in the denominator. Maybe I'll try something, okay? I have to get creative here. I'm going to go 3 there. Therefore, there's your 3 zeros right there. Okay? And then in the numerator, you just go 125. 125. And do you remember your place values? I don't know. Do you remember that? These are your tenths. These are your hundredths. This is your thousandths, right? The THS always, I get a kick out of pronouncing those. Right? So there, that's where your thousands come from. Okay. So if you want to look at it that way, there we go. Okay, now you gotta grab a ruler, or you don't have to have a ruler, but I'm gonna extend these ones here. We're gonna cross that off there, and I'm gonna give you a bunch of examples here to fill in. How many rows? Let me see here. 1, 2, 3, 4. 1, 2, 3, 4. We're gonna add 4 rows to this, and I'm gonna fill in various ones. 3 over 7. I'm gonna give you 75.25%. I'm going to give you 0.46. I'm going to give you 4 over 11. And I'm going to highlight the ones that are given. That way, if you fill this in, you know which ones, where we started. Okay. You with me? I need to do a lot of intro, right? I can't just jump right in and, right, you're going to be like, wait a minute. So fill in this chart on your own, right? Try this, fill this in, and see how it goes for you. I'm going to calculate some probabilities today. So let's see here. 3 over 7, what does that turn out to be? It turns out to be 0.43. We just did that actually previous. And it's 42.86%. How come, Mr. Dirksen? How does that make sense? 3 divided by 7, right, gives me, if you round it to 2 decimals, you need to take the 8 that bumps that 2 to a 3. So this would be the correct answer. Unless you chose to go 4 decimals, then it would have been 42.86. As long as you do that, that's fine. I'm more is better. Unless it's money, then you have a problem. Okay. So there it is. And then this one, getting into a decimal, just divide that by 100. So it's actually this, right? And as a fraction, right, you go 1, 2, 3, 4, right? There's 4 decimal places. So it's 10,000. This one is 46%. That should have been pretty easy, right? And then here it's 46 over. Yeah, there we go. You're a bright bunch. That's good. 4 divided by 11 is 0.36, right? And then as a percentage, it would be 36.36%. All I'm asking you is to round consistently, right? So if you had done this, it's fine, right? It is still correct. Okay, moving on. We're done with this chart. I will probably tomorrow give you an AC that looks like this. but right now we're going to move on. So go to page 146. Okay. I want the bottom part here. New skills. Working with experimental probability. I want you to highlight, circle it. Right? I'm going to refer to it as EP, right? Experimental probability. And I will put that on the. This is a little bit wordy here, but again, experimental probability. It's during an experiment or trial, right? To the total number of trials conducted. So the key word there is trials, right? Trials is the key word. That should give it away that this is experimental probability territory. Okay. Let me just highlight a few things. These are expressions of probability. Probability is a prediction, right? How likely it is for an event to occur. The formula is again right here. That's worth highlighting, maybe boxing in. But you know what? They don't give you the other one. There is a probability of something not happening, correct? If there's a probability of you passing, there's a probability of you not passing. If it's a probability of raining, there's a probability of it not raining. So can you do that here? Probability, you know how we say not in math? We actually put a little bar on top of it like that. You're saying the probability of this not happening is A not occurring over total. Okay. Question. What do these always add up to? Something happening and something not happening. That's right. Does that make sense? 100%. Yeah. So if I tell you that it's a 60% chance of snowing tomorrow, what's the probability of not snowing? How did you do that? Why? How did you come up with the 40? Tell me what you did in your brain to come up with the 40. Good. I hope you understand that I'm going to do that from time to time. Okay. Experimental probability is calculated based on measuring occurrences, right? There's a sample data set or trials, right? Using the results of the sample or trial, you can make predictions of the likelihood of future occurrences. Can you highlight this or underline? You can make predictions of future occurrences. So I want you to write that nice and big. You have to have this on your study sheet. Right at the only place on this page is the bottom here where that fits. So if you want to make a prediction, right, you take the probability of the event, okay, like that, times the greater, right, larger sample. Okay. This needs to be on your study sheet. Everything that I box in. If that's the bare minimum that you have on your study sheet, you're gonna be better off than not having one at all. Right? Make sure this is highlighted, that sticks out. I'm gonna actually do that, right? When you look through your notes, let's say you're preparing for the exam, right? There it is, it sticks out. And now let's do some math. Let's solve a problem. Okay. I think you've heard enough now, introduction, terminology, all of that. You're good? Right. Make sure you follow along here. Georgina bought a bag of bulk candies. She counted them and found that 15 were red, 10 green, 12 purple, 13 orange. Calculate the probability of a randomly chosen candy. By the way, guys, this is always implied. As soon as you peek, like my son, like if we do, you know how I chew those candies? He always likes his apple, so he always peeks. Like, no peeking. You just put your hand in and you grab, right? So then the probability is obviously not going to work out. But if it's random, then yes, we can go with this. Okay. So what is the probability of a random candy being red? Okay. Express the probability as a fraction, decimal, percent, and in words. Sure, we'll do that. Okay. Go ahead and do this. Before you do anything, guys, probability, we're on page 147, and you need to figure out the total. Let's figure out how many candies are there in the first place. So 15 plus 10 plus 12 plus 13, if you just add them all up, what do we get? Yeah, we get 50 candies. When you're dealing with probability, it's very important to have your total. Okay. What are the total possible options that I have? Right? So probability of red, how many red ones are there? There are 15 red ones out of 50 possible candies. Okay. Let's turn that into a decimal. I go comma, I don't go equal. You will see that right now because we are rounding to a certain degree most of the time. Okay. So 0.3, which is, we're on page 147, which is 30%. Okay. Which is, how could you do this in words? There's many options here. 15 out of 50. You could say 30 out of what? 100. So you choose. Is it too confusing to have multiple words there? Maybe get rid of one. Maybe just copy that one. Right? I based it on the fraction here, but if you base it on the percentage, percent is 30 out of 100, right? B. What is the probability of a randomly chosen candy being green or purple? This is a little different, right? Green or purple. Make sure you write this down, okay? I don't know in math, I don't know if people have told you as teachers, or in math is what kind of operation? Anybody remember or? Out of adding, subtracting, multiplying, and dividing, what would you say or? Or is actually adding, especially in probability. Okay, so go plus. So that means that you need to add your greens. How many greens are there? 10. And how many purples? 12. But we're still out of 50, correct? Okay. 22. So you're saying whether you get a purple or a green, it doesn't matter, right? So the chances are higher of getting either one of those, right? So let's get that as a decimal here. 22 divided by 50, 0.44. That'd be 44% because there are no further decimals. And that'd be 22 out of 50. I'm not going to do the words anymore after this. That's all I'm going to give you in terms of examples when it comes to that. C. We're going to make more questions here. That's why I left that whole page blank, okay? Watch this. If the distribution of the colors in a bag of 1,000 candies is the same, how many would Georgina expect to be red? let me backtrack though. What I'm going to say is you're making a prediction. Write this down. So basically what is happening here, you have a small bag of candy. Let's just draw a small bag here. I don't know. Right, the candies are in there. And now you're getting this big one with 1,000 candies, right? There's a little bit of a zip tie there. There's more candies here. Here you have 1,000. How many did we have in the small bag? 50, right? 50. So you're making a prediction. So watch how you do this. If you didn't write down the formula on the previous page, here it is. Prediction is equal to, we want to know how many reds we have in the other one, right? Can we not whistle? Is that, sorry, Zach. I'm just a finicky guy. I can't focus if there's a noise, sorry. I know you're having fun. Prediction is, probability of a red is 15 over 50, correct? And you're going to multiply that by, what did the formula tell you? The larger sample. And it's 1,000 candies. And Zach already answered, right? He told us it's 300, which you're correct. So I just want you to know, what do you do when this is happening, guys? You know, they always taught you bed mass, right? Bed mass. But here, bed mass. Did you know that when addition and subtraction are happening, it doesn't matter which one you do first. If you do division and multiplication, it doesn't matter which one you do first. If those are the only two present, it doesn't matter. So you can go 15 divided by 50 and then times 1,000, or you can go 15 times 1,000, then divide by 50. It's up to you. Because there are brackets, I'm going to do the division first, and then I'm going to multiply that by 1,000. And there you have it, 300 candies. That's what they do all the time, right? Like that's why they do polls all the time. That's why you get a free burger if you answer questions, right? A&W, right? Because they want your opinion so that they can make predictions. What can we do to sell more, right? What can we do? Hey, if this is the case, what can we do to do more, right? So D, I'm going to ask you a question here. How many candies? Write this down. How many candies are expected to be orange, comma, in a bag of 3,500 candies? How's that one? That's like Halloween on steroids, right? 3,500 candies. Too much candy. Sorry? Candy. These are just loose bulk candies that you buy at a store. Yeah. Okay. How would you do this one? Same way. Prediction? What do we need? What probability do we need? Yeah, which is the probability of orange. Hey, I have an orange highlighter. There we go. Probability of orange is, how many oranges are there? 13. Put this in brackets, right? It's nice. That's the probability of orange, and then multiply that by the larger sample. Okay. So we go 13 divided by 50, multiply that by 3,500, and you have 910 candies. Actually, orange candies. Okay, orange guys. Question. What if your answer is a decimal? What if it had been 909.37 rounded, right? Look, read the situation. I don't care if you round up or down, as long as it's a whole number. The province is okay with that. Some of you are just going to follow the rounding rules. I look at the question, right? Number of infected people. Would you go up or down? I would go up just to be safe, right? Like there could be that extra person infected, right? And so forth. One more here. Ready? State the probability of the candy not being green. Probability of not green. That's very important. Yeah, in the bag of 50. We're going back to the 50 bag. Yeah. So basically, this is what I'm asking you for. If you weren't here for it, a bar on top of something means not. So probability of green and then the bar, it means not green. I can tell you this, it's going to be out of 50. The question is, what's the numerator? Don't yell it out, just do it. Just figure it out yourself. Okay. This is how I would do it. I don't know about you. Watch how I'm going to do it. I'm going to take the 50. Those are all the candies, right? Which ones do you not want? Green. How many greens? 10. So this ends up being 40 out of 50. Did you know that you can cancel trailing zeros, right? I'm sure you know that. This is really 4 out of 5, which is 0.2, which is, no, 0.8, sorry, 80%. Question, what would be the probability of drawing a green one? No, just look at the numbers. Probability of drawing green. What would it be? 20 or 0.2 or 1 out of 5, right? Depends on what you're looking at. That's the probability of drawing green. Just by looking at these numbers, you can already tell what that will be. Okay, keep going. I want you to, what we've learned, apply what we've learned, and go to the next page here. There's a blank spot in 148, but when it says build your skills, okay, everything that follows build your skills, which is 148 and 149. There's one question that's snuck into 149, a C part, okay? So I want you to work on this now. Okay, so everything that follows build your skills. You know how to do everything. You know how to predict. So everything should be answerable. Okay.